In this lesson, we're going to talk about midpoints and medians and use their definitions to construct geometric proofs. So first, we're going to start with midpoints. Now, dead giveaway, because of course the title is midpoint, but also you'll notice that midpoint is right in the given. So it says D is the midpoint of AB. Now that's really important because what that means is when you have a midpoint, you're given the middle. And hopefully we remember that. The midpoint is the middle of a line segment. So that means that D is right in the middle of AB. Closer, not closer to A, not closer to B, right equally in between them two. So that means that these two line segments, AD and DB, are congruent. So let's think about how that can help us in a proof. In a proof, we're always looking for sides and angles so we can get closer to a method. In this case, a midpoint is giving me two congruent sides. So let's see how we can write that in a proof. We're starting off very simply with just our given D is the midpoint of AB, and that's given. And now we're going to write the two sides we now know are congruent. So we're going to write that AD is congruent to BD. And the reason for that is a midpoint divides a line segment into two congruent halves. Right? So now we have a side. So it's beautiful. When they give us a midpoint, I'm just one step away from getting one side being congruent to another side. Now, a midpoint is a point, but what is a median? Now, a median is a little bit different, so let's check the title here, median. And if I'm given a median in my given, that means I'm given a line segment, not a point. So it's saying that this AS is a median of this triangle. Now, it's really important to remember, and I'm going to draw us a little diagram that we usually put in our things to remember. So when you are given a median is a line segment, right? But just like that triangle we just saw with a median, that line segment goes to the midpoint. Okay? So a line segment goes to the midpoint, which then gives us two congruent sides, or two congruent halves as we write it. So a median is really just going to go ahead and bring us to that midpoint, and that's going to give us to the two congruent sides. So let's just zoom in real quick. Again, the median is the actual line segment. Let's make that a little bit thinner. The median's the line segment, and this point here is our midpoint. But as you know, whenever we have a midpoint, it breaks it into two congruent halves. So median is still giving us those two congruent sides, just at a little bit longer of a process. So let's go back here. So we're going to start writing this proof. So again, if AS is a median, that means that this point A here must be the midpoint, right? And if that's the midpoint, just like we saw in the last proof, this is now congruent to this, right? All right, so let's see how it gets written in a proof, all right? We start with AS is the median of RS, and that was given, okay? Next, we have to define what the midpoint is, and we now know that A, make that a little bit thicker, A is the midpoint of RT, right? And this is just the definition of a median. A median goes from the vertex of a triangle to the midpoint of the opposite side. All right? And now we know that RA is congruent to AT because a midpoint divides a line segment into two congruent halves. So again, these last two steps are the same as the midpoint routine we had just learned. So that's everything there is about medians and midpoints. It's just giving us two congruent halves, which gives us sides, which helps us to get to our method. Now, I do want to point out before we move further on, we added this to our things to remember, but this is also in our special steps and proofs. So this first page, it's not on, but if you take a look at the second page, there's two places you want to look. Right here, you'll see midpoint, right? And it's the same routine we just had. Just keep in mind that the only thing that's going to change from this routine from proof to proof is the letters, because the letters in the diagram will change. So in this case, it's saying B is the midpoint, so CB is congruent to DB. And then if I scroll down to median, which is this guy here, it's the same exact thing that we just did, just with different letters. And I also would be remiss if I didn't point out that this is the same as midpoint. Median's just one extra step, and then it's just a midpoint routine. Okay? So in this case, the median is AB, but that leads me to this midpoint of B, which leads me to those two congruent sides. So let's see if we can write a proof or two using our newfound knowledge of medians and midpoints. So this first example, again, I kind of give it away in the title when I say midpoint proof, but then again, so does the given, right? Let's mark our givens one by one. So the first given I'm going to mark is angle E is congruent to angle C. The next given I'm going to mark is that AE is congruent to, I'm going to use a different color because I feel like that's too close to the purple. AE is congruent to BC. And last but not least, our final given here, D is the midpoint of EC. So that means D is the midpoint. Now that doesn't give me a side or an angle right away, but if I go, I'm going to put a little +1, because if I go one more step, I'll get that this side here is congruent to this side here, which is extremely helpful. Okay, now I really strongly feel that I have my method that I need. I can tell if I cover up one of these triangles that my method is going to be side, angle, side. So I'm going to go ahead and start constructing this proof. Step 1 is going to be my first given, and that's angle E is congruent to angle C, and that's given. And again, that is a one and done given. It gives me my angle right away. So I'm going to use a highlighter to make it a little bit more emphatic. This angle is done. All right, given number 2. It says that AE is congruent to BC. And the reason for that is given. Now that's beautiful too, because that gave me a side. So now I see, let me get some green highlighter in here. I see that this side is done. Again, it doesn't matter which S you check off. I'm just seeing, if I have everything I need. So now I'm going to go to my third given. And again, I already have 2 out of the 3 for my method. So third given. D is the midpoint of EC. And that's given. Again, if you're not sure where to go from here, there's 2 places I want you to look. A midpoint brings me to 2 congruent sides, which I can see from here, right? Or I can go to my special steps and proofs and look at my midpoint routine, right? And it's just using the definition of a midpoint. Okay, but since we're doing it together right now, I'll just go ahead. Which 2 sides do I know are congruent? Well, step 4, I know that ED is congruent to CD. And what's the reason for that? It's the definition of a midpoint. So you're going to write a midpoint divides a line segment into 2 congruent halves. Done. So now I have my final side finished, and that means I'm ready to write my final proof statement. So last but not least, I'm going to go ahead and I'm going to write that triangle ADE. So let's see. Step 5, triangle ADE is congruent to triangle BDC. And the reason for that is side, angle, side is congruent to side, angle, side. And we're done. So the midpoint routine is extremely helpful in giving us a side. And it's a nice little 2-step process, nothing too crazy. So let's go on to medians. So I'm going to go ahead and take a look at this given, or this proof, asking us to discuss medians. And I'm going to go ahead and mark it as I go. I'm not going to jump ahead. I'm just going to go ahead and go for it. So the first thing it's telling me is that PR is congruent to QR. Okay, that's a side. I love that. Then it's going to tell me that RPS is congruent to RQS. Beautiful. Then it's going to tell me that RS is a median. Now, I know that RS is a median, that's right here, but a median leads me to a midpoint, which gives me two congruent halves. So this ends up being extremely similar to the last proof we did, especially in that our method is going to be side, angle, side, but we're just going to have an extra step because we're given a median instead of a midpoint. But remember, a median goes to a midpoint, which goes to two congruent halves. Okay, so let's see if we can start off. Statement 1. PR, make that a little bit prettier. PR is congruent to QR. And that's given. So that is a one and done given. This side is finished. Next, angle RPS is congruent to angle RQS. And that's given. That's a beautiful one and done given. That gave me an angle. All right. Now, last but not least, I'm going to write my very last given, which was that RS is a median. Okay, now a median should lead me to a midpoint. So if I look at my diagram, what's my midpoint? S is my midpoint. If you don't see it, it's right here. S is that midpoint, right? So for S is the midpoint of PQ. And why is that? So we're going to go with our definition of a median. A median goes, zoom out a little bit, from the vertex of a triangle to the midpoint of the opposite side. Okay? So now that I have a midpoint, that's beautiful. Now I have two congruent sides I can get to. So now my step 5 is going to be that PS is congruent to QS. And the reason for that is a midpoint, again going right into my midpoint routine, divides a segment into two congruent halves. Okay, so now I have my two congruent halves. So again, that last side is finished because I have a side being congruent to another side. So that means last but not least, I'm finished. I can go ahead and do this proof statement here. So my last statement, statement 6, is going to be that triangle PSR is congruent to triangle QSR. And the reason for that is side angle side is congruent to side angle side. And we're finished. So again, the median routine has 3, including the given, because it's one extra step. The midpoint only has 2, but they're both extremely helpful givens to helping us get to a side, which is also always very helpful when we're working towards our method. So this has been talking about medians and midpoints. Remember, use your special steps and proofs to help guide you through. It is not cheating unless it is on the test. If it is before the test, it is being resourceful, and it is strongly encouraged. If you have any questions, please let me know.